Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll try to solve that integral between 0 and pi of sine square of x minus sine to the power of 3 of x dx. Because of this minus here, I can split it into two integrals. It becomes integral between 0 and pi of sine square of x dx minus integral between 0 and pi of sine to the power of 3x dx. And to facilitate our life, I will solve that integral first, and then I will solve the second one second. So I'll work on that integral of sine square of x. I know that sine square of x, I can write it, there is a trigonometric identity formula that said sine square of x is equal 1/2 times 1 minus cosine of 2x. This is one of the trigonometric identity formula that I will be using here. Let's write the 2 in a better way. Okay, so my integral between 0 and pi of sine square of x dx is equal, I can put the 1/2 outside the integral between 0 and pi of 1 minus cosine of 2x. That becomes very easy to solve. And because of this minus, I can split it into two integral. So I will put the 1/2 and I open big quotation integral between 0 and pi of dx minus integral of cosine of 2x dx between 0 and pi. And integral of dx is x, so it becomes 1/2x minus, and for the second integral, like, it's easy to be solved, but like to do it step by step for the one who needs it that way, I say let u equal cosine, it's equal to x, so my du is equal to dx. That means my dx is equal du over 2. So that integral, I can write it of cosine of u du divided by 2. And cosine of u is sine of u, and then sine of u is sine of 2x, because u is 2x. So let's, now that I explain it, I know that this is equal of integral of cosine is equal to sine of 2x, but there is 1/2 because of the du that is here. So let's do it right away. So this become, there is the 1/2 that is here, I have to put it here, times 1/2 sine of 2x, and all those two, let's erase this, and let's erase this, and all those are between 0 and pi. So it becomes 1/2x minus 1/4 sine of 2x between 0 and pi. Yeah. So now I have to replace x by pi first. So it becomes 1/2 pi minus 1/4 sine of 2 pi. Sine of 2 pi is like sine of 0, because on the trigonometric circle, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2, and this is 2 pi here. So sine of 2 pi is like sine of 0, and sine of 0 is equal to 0. Sine of 2 pi, which is equal to 0, this is equal to 0. And then I put minus and I open my parentheses. Let's make it a little bit smaller, and 0. Minus, and I open my parentheses, and now I have to replace x by 0, 1/2 times 0. I know that all that is equal to 0. Minus 1/4, sine of 2 times 0 is sine of 0, which is equal to 0. Yeah, and so all that become 1 over 2 pi. So let's highlight it because I will add it to my final answer. And now this is working on that integral here. Now I will be working on this integral here, the minus sine to the power of 3x dx. So I will do integral minus sine of to the power of 3x dx, and this is between 0 and pi too. Now we said, I keep on saying it on my previous video, I have to make it to the power of 2 to be able to use the trigonometric identity. So this is equal minus between 0 and pi of sine to the power of 2 x times sine x dx. But another trigonometric identity formula that said sine square of x plus cosine square of x is equal to 1. Okay, you're gonna ask me why I did not use it here for this integral. Because this integral, there is only sine square of x and there is nothing else. So I have to have sine and cosine in my integral to be able to make my life easier. Here I can have it sine and cosine because I can replace sine square of x by 1 minus cosine square of x, and I would have sine of x, and you're gonna see when I take my u. So this is equal minus 0 and pi. Instead of sine square of x, I can write 1 minus cosine square of x times sine of x dx, because this is the sine square of x is equal 1, and then this come here, it become minus cosine square of x. Now I say let u equal cosine of x, so my du is equal minus sine of x dx. So minus du is equal sine of x dx. You see why I have cosine and sine, so I take u is equal to sine, and my du, here it is, my du, and this is my u. Because I took let u equal cosine of x, so I have to find the new boundaries here. So cosine of 0, for this boundary, cosine of 0 is equal to 1, and cosine of pi is equal to minus 1. So my integral become minus integral between minus 1 and 1 minus u square, and instead of dx, I would write, instead of sine x dx, I will write minus du. Yeah? Because usually, we can leave it that way, like this minus with that minus become plus. Let's do it. It is plus integral, and if I flip my integral between, the 0 was on the lower bound, and cosine of 0 is equal to 1, so the lower bound is equal to 1, and the upper bound, the cosine of x is equal to minus 1. That's it. And usually what I do is I put the lower number in the lower bound. So if I flip it from minus 1 to 1, I have to change the sign of my integral, so it become minus again, because minus times minus is equal to plus. But by flipping it, no, I will change it inside. I'll keep it plus here, and I will put u square minus 1 instead of minus u square plus 1. So u square minus 1 du. That's easier. So now, because of that minus, I can split it into two integral. So it become integral between minus 1 and 1, u square du, minus integral minus 1 to 1 of du. And this is equal u to the power of 3 divided by 3. and this is equal minus u, and all that between minus 1 and 1. And here I have to replace y by 1 first, and then minus, replace it by minus 1. So it becomes 1 over 3 minus 1, and then I put minus and I open my parentheses. Minus 1 to the power of 3 is minus 1, and minus 1 times minus is plus 1. So it becomes 1 to the power of 3 minus 1 plus 1 to the power of 3 minus 1. So all that is equal to 2 divided by 3, not to the power of 3, minus 2. And if I want to have a common denominator, I multiply here by 3 and I multiply here by 3. So it becomes 2 minus 6 divided by 3, which is equal to minus 4 divided by 3. So my second integral is equal minus 4 to the power of 3. By second integral, I mean minus integral of sine to the power of 3x dx is equal minus 4 divided by 3. And the first integral was integral between 0 and pi of sine square of x dx. So because I have my original, and this is between 0 and pi. My original integral that I was solving, it was sine to the power of 2x minus sine to the power of 3x, all that dx between 0 and pi is equal, the first one was 1/2 pi, 1/2 times pi, and the second one minus 4 divided by 3. And that would be the answer for that problem. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.